The last parent function that we're going to talk about in this section is the square root parent function. And that square root parent function is y equals the square root of x. So I want to take you through finding ordered pairs that match that function, and then we'll talk about how the transformations of the square root function are going to work. And they're very similar to the ones that we've already covered in this section. Normally I choose positives, negatives, and 0 to plug in for x so that I can generate my ordered pairs. But if you think about that, if I use the normal numbers that I have been using in all the other functions, if I plug in -3, well, the square root of -3 right now doesn't exist. We don't know what that is. We won't know what that is until we get into imaginary numbers. And that's going to be the case for any negative number underneath a square root symbol. The number that you plug in, if it's negative, okay? And it produces a negative underneath the square root, there's no way we can solve that, at least not yet, okay? There will never be a way to graph it. In your imaginary number system, you can't graph something like that. So we have to stick with 0 and we have to do positives, okay? So if I plug in 0, the square root of 0 is 0. The square root of 1 is 1. Square root of 2, well, that's going to be 1.4 something. It keeps going. So I'm going to be really specific with the type of numbers I choose for x so that I can get nice whole number answers to really see what my graph is doing. Because if I get a bunch of decimals here, it's going to not be real accurate when I go to graph it. So let's try numbers that are square numbers. So if you think about it, after 1, the next square number would be 4. If I plug 4 in there, the square root of 4 is 2. The next square number would be 9. The square root of 9 is 3. So when I go to graph that, I'm going to start with this ordered pair 0, 0 and go from there. So if I go to my graph, 0, 0, 1, 1, 4, 2, and 9, 3 are my ordered pairs. And if I graph those, my square root function looks something like that. So this is the parent function of my square root, y equals square root of x. Let's think back to your knowledge of what happened in the other parent functions when we put a negative in front. Now remember, that's understood to be a -1 in front of that square root of x. We still have to consider whatever's underneath the radical has to be positive, otherwise we can't get an answer. So I'm going to choose 0 and then some square numbers like 1, 4, and 9. So I'm choosing the same numbers to see what happens. Well, the square root of 0 is 0. 0 times -1 is 0. The square root of 1 is 1. 1 times -1 is -1. The square root of 4 is 2. -1 times 2 is -2. The square root of 9 is 3. -1 times 3 is -3. So if we look at what that does to our graph, now think about what it did to our graph in a quadratic or in an absolute value function. It flipped the graph across that x-axis. Okay, let's see if the same thing happens here. So I'm going to put this one in blue when I graph it. So 0, 0, 1, -1, 4, -2, then 9, -3. If I draw my graph, it looks something like that. And just like before, putting that -1 in front does take that parent function and flip it across that x-axis like we would expect. So that's y equals square root of x. Okay, I've got the next two that I want to consider color-coded here. The blue one is the one we just did. In red, I've got y equals the square root of -x. Now, if you think about what that means that we've got a -1 in front of the x. So you need to think about this. What kind of numbers do I need to plug into this that will make what's underneath that radical a positive so that when I take the square root, I can actually get a number that works, okay? What kind of numbers do I plug in for x that would make this positive? Well, if there's a negative in front, I need to plug in 0, it would work, and then negative numbers. So I'm going to reconsider what I plug in for x. This time, I'm still going to do 0, but instead of doing 1, 4, and 9, I'm going to do -1, -4, and -9. So it's going to be helpful to think ahead and think about what numbers can I include as my x, or include in the domain, that would actually give me an answer that works, okay? Because if I plug in a positive number here, well, if I plug in 1, -1 times 1 is -1, I can't take the square root of a negative. And that same thing is going to happen for no matter what positive number I plug in. So I'm going to choose negative numbers this time so that I can get whole number answers. So if I plug in 0, I still get 0. If I plug in -1, -1 times -1 is 1, square root of 1 is 1. Plug in -4, -1 times -4 is 4, square root of 4 is 2. Plug in -9, -1 times -9 is 9, square root of 9 is 3. Now again, we've talked about this already. Desmos will work for all of these. If you don't understand how this works, there's no way you will be able to analyze the graphs later. So that's why we're doing this. I realize Desmos will do it, and I don't have a problem with you looking at Desmos and doing it that way. But the reason I'm explaining it here is so that you understand where those ordered pairs are coming from for your graph, because it's going to make a huge difference later if you understand where those numbers come from. All right, so if I graph this, 0, 0 is here, -1, 1, -4, 2, -9, 3. And so I have kind of the same shape graph, but it's been flipped from the parent function, it's been flipped across the y-axis. The direction that it's going is going to depend on what we've done different to that parent function. All right, so let's move over to the green function now. Notice in this one, I've got a negative on the outside and on the inside, so I have to consider what's going to happen when I have my graph. Now, think about that. We know that negative is going to flip it across the x-axis, but what did we learn about this negative on the inside does to it? This one will flip across the y. If it does that, my prediction is it's going to go in this direction, but let's see what happens, okay? So I'm going to do the same thing. I have a negative underneath, so I need to consider what will make that underneath positive. Well, the only thing that's going to make the underneath x positive is by choosing 0 and negative numbers. And of course, 0 is neither negative nor positive. If we choose 0, square root of -1 times 0 is square root of 0, which is 0. -0 is 0. I'm going to choose negative numbers like -1, -4, and -9. When I plug in -1, -1 times -1 is 1. Square root of 1 is 1. -1 times 1 is -1. -4. -4 times -1 is 4. Square root of 4 is 2. -1 times 2 is -2. And then -9 times -1 is 9. Square root of 9 is 3. -1 times 3 is -3. That gives me my ordered pairs. And so then I have 0, 0, -1, -1, -4, -2, -9, -3. And so what I had predicted is happening here. It's flipping across the x and the y-axis to give me the other function, okay? So the next thing I want to consider is what happens when we have a number on the inside and a number on the outside to see what happens to our graph. Now let's just think about it. The parent function here was black. So here's my parent function, and this is the basic shape of my parent function. So if I have a parent function and I have something on the inside and something on the outside, the same relationship is going to happen. Whatever's on the inside tells us to move right or left, opposite of what we think. And then on the outside, it tells us to move up or down, the same direction as what the sign is telling us. So up if it's positive, down if it's negative. And then if we have a negative in front, then that's going to flip that function across the x-axis. Flip it upside down. So the same relationship holds true for the parent functions. The only new relationship we've got here is if we end up with a negative inside, it flips it across the y-axis. So a negative on the outside flips across the x, negative on the inside flips across the y, and then we still have the same relationships with the inside and the outside functions. So let's see how translations work with square root functions. I've got my parent function here, still graphed in black, and I want to look at this function that has a translation. Look at the inside here, underneath the radical. I've got a +3. Now before, with our work with parent functions, we said that if you have something that is plus on the inside, the plus tells us to move left 3. And then if you have something here with a -2 on the outside, that minus tells us to move down 2. So my prediction is that from my parent function, each of these ordered pairs are going to move left 3, down 2. So my first part of my graph would be here. So let's see if that happens, and then graph that new function. Now, when I plug in numbers for x, I want to make sure I get square numbers on the inside. So I'm going to have to be real purposeful about what numbers I choose. Okay, so now let's think about this. How can I end up with a 0 on the inside? And this is why Desmos makes this a lot easier. You don't have to think about all the numbers, okay? Desmos just does it for you and it makes it easy, okay? So I really have to put a lot of thought into choosing my numbers here. So if I choose something, I can choose something to get 0 underneath. Well, -3 plugged in for x would give me a 0 underneath. So that's the first thing I'm going to choose. So if I plug -3 in, I've got -3 plus 3 is 0. Square root of 0 is 0. 0 minus 2 is -2. So there's my first ordered pair. Now I want the next square number in here. What can I plug in here that will give me a 1 underneath? Well, if I plug -2 in for x, -2 plus 3 is 1. Square root of 1 is 1. Minus 2 is -1. So that works. Gives me a nice whole number. What can I plug in here to get a 4 inside, the next square number? Well, if I plug in 1. 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. So if I plug in 1, I get 0. So let's see, 6 in for x. That will give me a 9. So square root of 9 is 3. 3 minus 2 is 1. So that gives me some nice whole numbers to plug in to make a graph. So -3, -2, and I believe that's where I had put that dot saying that I thought that's where it would be. -2, -1, 1, 0, 6, 1. So here's my translation. That is my new function. Did in fact all of these points move left 3, down 2? Well, let's look at it. Left 3, down 2. This one, left 3, down 2. This one, left 3, down 2. And the last one, left 3, down 2. So go ahead for this one and think about it. Predict where your starting point is going to be and predict what the shape of that graph would be. Just think about that for a second and see if you can figure out what you think that might be. I'm going to go ahead now and plug in points. I want to make sure I get whole number answers here. Okay, so 1 minus 1 would give me 0 inside. So I'm going to plug 1 in for my first number. 1 minus 1 is 0. Square root of 0 is 0. Times -1 is 0. And 0 plus 4 is 4. So 1, 4 is my first ordered pair. Let me see. To get my next whole number, let's see what we can plug in to get 1. If I plug 2 in, I will get a 1 inside. So let's try that. 2 2 minus 1 is 1. Square root of 1 is 1. Times negative 1 is negative 1 plus 4 is 3. So there's my second ordered pair. The next whole number is 4. So what can I plug in for x that will give me a 4 inside? Well, 5 minus 1 is 4. So 5 is the next number I'm going to choose. 5 minus 1 is 4. Square root of 4 is 2. Negative 1 times 2 is negative 2. Plus 4 is 2. And then 9 would be the next one. What number can I plug in to get 9 inside? Well, that would be a 10. 10 minus 1 is 9. Square root of 9 is 3. Times negative 1 is negative 3. Plus 4 is 1. Now, let's predict what we think might happen. On the inside, we have a minus. And on the outside, we have a plus. So I'm thinking that's going to be moving right 1, up 4. Okay? So I'm going to predict that from my original starting point, I'm moving right 1, up 4. Is that in fact what we've got here? 1, 4, right 1, up 4. Yes, it is. 2, 3, right 2, up 3. Okay, now let's think about that. Looks like it's going in a different direction here. Well, that makes sense to me because that negative in front, didn't it flip this upside down? But when we also have the translation, it's going to be flipped upside down, but it's just moved to a different location. Okay, next one is 5, 2. And the last one is 10, 1. And looking at that, there is my my square root function for this translation. So that's square root parent functions.